In this video, we are going to look at simplifying powers of I. First, we need to discover the cyclic nature of the powers of the imaginary unit I. What we mean by cyclic nature is that the powers of I follow a cycle or a pattern. And once we recognize that pattern, it will help us to calculate powers of I. Remember our definitions. The imaginary unit I is equal to the square root of -1, and so it follows that I squared equals -1. So let's calculate the powers of I to the first through I to the eighth to see if we can find the pattern emerging. Well, I to the first power is just I. Anything raised to the first power is just itself. By definition, I squared is -1. The rest of these powers are based on these two powers, I to the first and I to the second. I cubed can be composed of I to the first power times I to the second. And the reason why I'm breaking it up that way is because our exponent rules tells me that when I multiply powers, I should add the exponents. So I to the first times I to the second is the same as I cubed. Well, from that, we can simplify I cubed. I to the first power is just I, and then times I to the second power, which is -1, gives us I times -1, which gives us -I. Let's start highlighting our final answers so we can see the pattern emerge. I to the fourth can be I squared times I squared because 2 plus 2 is 4. Well, we know I squared is -1, and the other I squared is also -1, and -1 times -1 is +1. So far we have I, -1, -I, 1. Let's keep going. Let's look at I to the fifth. We can make I to the fifth from I cubed times I squared. Well, I cubed we know is -I. I squared is -1. Two negatives multiply to a positive, and I times 1 would just give us I. I to the sixth can be I to the fourth power times I to the second, because 4 plus 2 is 6. We found that I to the fourth power is 1, and we know that I to the second power is -1, so that equals -1. I to the seventh is I to the fourth power times I to the third, because 4 plus 3 is 7. I to the fourth power is 1. I to the third power is -I. 1 times -I is -I. And finally, I to the eighth. We can do this by raising a power to a power. If I have I squared raised to the fourth power, that tells me to multiply exponents. So I to the second power raised to the fourth power gives me 8. We know that I squared is -1. So -1 to the fourth power is +1 because 4 gives us an even power. And there's our final answer. So let's check out what we have here. I, -1, -I, 1. I, -1, -I, 1. So what we have here is two cycles of the pattern. Here's one cycle, here's one cycle. So the cycle is made of 4 different values. So every time you hit that fourth value, you're going to start over again at the beginning of your cycle. So after I to the eighth should come I to the ninth. And if we notice the cycle now, the cycle should start over again after I to the eighth. It should go back to the beginning of the cycle. I to the ninth power should just be I to the first, or I. Well, let's verify that before we move on. And let's look at the patterns that we need to know. So these are basically the 4 values that we need to know. And in fact, you could even get by with just the first 2, I first and I squared, because any other power of I can be composed of I to the first and I squared. But these are the 4 that you're going to notice in your cycle. All right, so let's look at I to the ninth. We can get I to the ninth by doing I squared to the fourth power, because that's 2 times 4, but then I need one more power, so I need to multiply that by I to the first, because that will give me 8 plus 1, which will give me the power of 9. So I squared here is -1 raised to the fourth power, and then I have times I. -1 to the fourth power is +1 times I is I. And that's our final answer. And that is what we predicted for I to the 9th over here. Let's do I to the 10th. That would be I squared to the 5th power, because 2 times 5 is 10. I squared is -1, and if you raise -1 to the 5th power, which is an odd power, your final answer is going to be -1. I to the 11th is I to the 2nd power raised to the 5th power. That gives us I to the 10th, but then we need one more power of I to make it 11. So I squared is -1 to the 5th times one more power of I, which gives us -1 times I, which gives us -I. And I to the 12th is I squared to the 6th power, because 2 times 6 gives me 12. So we have -1 to the 6th power. Since it's an even power, we get +1. Well, there we have it again. There's our cycle. I, -1, -I, 1. I, -1, -I, 1. So we completed another cycle. Since there's 4 values in the cycle, we can divide by 4 to figure out where we are in the cycle. Did we complete a whole cycle, or are we kind of halfway between one cycle and the next? So what we're going to look at is this chart next. For instance, what this is telling us is that I to the 5th is really equal to I to the 1st. Because if you do 5 divided by 4, 4 goes into 5 one whole time, which means I to the 5th has completed one whole cycle, but it has a remainder of one cycle left over. It has a remainder of 1 left over, which means it's only one value in towards the next cycle. So this remainder becomes the power on I. So one cycle means you have a remainder of 1. So I to the 1st power is just I. So I to the 5th should equal plain old I. All right, let's look at I to the 6th. We have 6 divided by 4 gives us a remainder of 2. So 4 goes into 6 one time, which means it did one cycle, but now there's a remainder of 2. So that would be I squared, which would be -1. 7 divided by 4 right here. 4 goes in one time, so that's one cycle, but now there's a remainder of 3. So it would be I cubed, which according to our pattern is -I, because it would be I to the 1st times I to the 2nd. And then I to the 8th. 8 divided by 4 is 2 complete cycles, because 4 goes into 8 two times with 0 remainder. It goes in evenly. Well, that's I to the 0 power. Well, that's just 1. And there we have our cycle. I, -1, -I, 1. So we can also use this dividing and using the remainder as our power on I to figure out what a power of I is going to be. So let's do some examples. Let's do I to the 38th power. I'm going to do it using powers, and I'm also going to do it using the division and the remainder. You can always start with I squared, because you know by definition that's -1, and you want to get as close to 38 as you can. Well, this is nice because 38 is an even number. So if I do I squared to the 19th power, since 2 times 19 is 38, I'm already at my 38th power. I squared is -1, raise it to the 19th power, and my answer is -1. Now let's do it using the remainder and verify that we get the same answer. I'm going to do 38 divided by 4, 9 times. 9 times 4 is 36, with remainder 2. Now, all the 9 tells us is that I to the 38th power has completed 9 full cycles. But what I'm concerned with is how many are left over until the next cycle, because that becomes the exponent on my I for my answer. So since there's a remainder 2, that's I squared, and by definition, I is -1. And you can see we get the same answer no matter which method we use. Okay, let's do one that's a little bit larger, in terms of powers anyway. Let's do I to the 253rd power. All right, we can break it down in terms of I squared. So you figure out how many times 2 goes into 253. Well, that looks like it would be 126, because 2 times 126 would give us 252, but then we would need one more power of I. So I squared is -1 to the 126th power times I. A negative 1 to the 126th power would be positive 1 times I, and our final answer would be I. All right, let's do it the remainder way. I would do 253 divided by 4, and 4 goes into 253. Let's start here. So we are going to have a 6. 4 goes into 13 3 times. 3 times 4 is 12. And we have a remainder of 1. So again, it's not the 63 that matters. That just means it went in 63 full circles or full cycles. It's the remainder of 1 that matters. So our answer would be I to the first, or just I. And again, we can see that we get the same result.